So here we are just to make you understand how to do the how to find the inverse Z transform using long division method. Let's do this problem. Okay, using long division method, find the inverse of the Z transform function. X of Z is equal to 1 plus 2 Z inverse by 1 minus 2 Z inverse plus Z raised to minus 2. Okay, and here first I'm going to assume that this function is a causal signal, and then in the second question I'm going to assume that this function is a non-causal signal. Okay, one thing that I have explained already, how to find the Z transform, how to find the inverse Z transform using long division method, but now you need to understand why we are applying that method. Like I said, that in the case of a causal signal, you have to start with the we have to start with the highest power of Z, and in the non-causal signal you have to start with the lowest power of Z. The reason why is you will be understanding after when we do this problem. Okay, so let's do this. So I'm going to assume that this signal, first in the first case I'm going to assume that this signal is a causal signal. So therefore that is X of Z is equal to, let me write this question again, 1 plus 2 Z inverse by 1 minus 2 Z inverse plus Z raised to minus 2. Okay, so here what I'm going to do is I'm going to now perform the actual division. So when you're performing the division, make sure that you leave some space in this region. Okay, start as much as possible from this side, because the process will go in this direction. Okay, so the more space you get over here, the better you'll be, the more answers you'll be able to find, right? So I'm going to start my division process. So my dividend is this one, 1 plus 2Z, and my divisor is this one, that is 1 minus 2Z inverse plus Z raised to minus 2. Okay, and your dividend is 1 plus 2Z inverse. Okay, this is your normal division that you have studied in school, normal division, right? All you have to do is aim for the first term to become 0, right? Whatever value you need to give over here, such that the first value becomes 0, right? When you subtract it, the first value should become, the first term should become 0. That's how you find the division. Okay, so here if I want to cancel out this first term, what I do is I just need to multiply this with 1. And when I multiply it with 1, this will become 1 minus 2Z inverse plus Z raised to minus 2. Okay, then I apply the subtraction, that is, then the signs will all change, right? Minus will become plus, plus will become minus. So 1 minus 1, this becomes 0, and your remaining term will be, it will be 4Z inverse minus Z raised to minus 2. Okay, so now I want to cancel out this term. So how do I cancel out this term? By multiplying this with 4Z inverse. So next term I'm going to multiply this is with 4Z inverse. So if I multiply this, then the first term will become the same. Then I need to simply find the value of the remaining terms, that is minus 8Z raised to minus 2 plus, this is multiplying these two, it will become 4Z raised to minus 3. Okay, and then I'm going to apply subtraction. So in that case, these two will get cancelled, and the remaining term will be, this is 8, this is Z raised to minus 2, right? The one is minus 1, this is plus 8, so that means it will be 7 Z raised to minus 2, and here it will become minus 4 Z raised to minus 3. Okay, now I want to cancel out this first term over here, so that means I need to multiply this one with 7 Z raised to minus 2. So when multiplying it, the first term will become same, and the remaining term will become minus 14 Z raised to minus 3 plus, and this will become 7 Z raised to minus 4. Okay, then I'm going to apply my difference again. So this is minus, plus will become minus, minus will become plus, plus will become minus, and these two will get cancelled, and the remaining term will be, this is 14 minus 4 is 10 Z raised to minus 3, and this is nothing but minus 7 Z raised to minus 4. Okay, and then what you're going to do is you're going to cancel, you want to cancel out this one, so you need to multiply this with 10 Z raised to minus 3. Okay, and so if you multiply it with 10 z raised to minus 3, you will get 10 z raised to minus 3. Here it will become minus 20 z raised to minus 4, and here it will become plus 10 z raised to minus 5, right? And when you do this, this will become minus plus minus. Okay, and then these two will get cancelled, and this is 20 minus 7 is 13 z raised to minus 4, and this is nothing but minus 10 z raised to minus 5. Okay, and then when I need to cancel out this one over here, so this will become plus 13 z raised to minus 4, which will then in that case, and this will become 13 z raised to minus 4, then this will become minus 26 z raised to minus 5, and this will become plus 13 z raised to minus 6, plus 13 z raised to minus 6. Okay, then this minus will become, and this minus will become plus, this plus will become minus, these two will get cancelled, and here this will become 26 minus 10 is nothing but 36, right? 36 z raised to minus 5 plus, and here it will become, here it will become minus 13 z raised to minus 6. Okay, then maybe I can do one more time, that is plus, I will need to cancel out this, so it will become 36 z raised to minus 5. So you will get over here, 26 minus 10 is 16, right? I'm sorry, 26 minus 10 is 16, right? 16, so it will become 16. Yes, 16. So now I want to cancel this, so it will become 16 z raised to minus 5 minus, and this will become minus 32 z raised to minus 6, z raised to minus 6 plus 16 z raised to minus 7, and it goes on, right? These two will get cancelled, and here you will have, here you will have minus, and minus becomes plus, plus will become minus, 32 minus 13, right? It will become, it's nothing but 19 z raised to minus 6 minus, this is nothing, 16 z raised to minus 7, right? Minus 7, and this thing goes on and on, right? So that means your x of z is nothing but, your x of z is nothing but 1 plus 4 z inverse plus 7 z raised to minus 2 plus 10 z raised to minus 3 plus 13 z raised to minus 4 plus 16 z raised to minus 5. Here you will understand why we are using this method to find the causal signal. Like I said before, when you are going to find the z inverse of a causal signal, you have to write the expression in such a way that it starts with the highest power of z. Here the highest power of z is 0, right? Because here it is z raised to minus 1. Here the power is minus 1. Here the power is minus 2. And here also the power is minus 1. So we start with the highest power of z if you want to find the inverse of a causal signal. The reason is because unless and until you do like this, then only you will get this kind of a value. That is, you can see here that the power of z are all negative. The power of z are all negative. What does this mean that the power of z are all negative? That it means that the numbers that you see here, or the coefficients that you see here, are all in the right side of the graph. Are all in the right side of the graph. If the power of the z are all negative, then it shows that these values that you see here are all on the right side of the graph. Or in other words, from here itself I can say what is my x of n. That is, my x of n is nothing but, let me write the next line. My x of n is nothing but 1, 4, 7, 10, 13, 16, and so on. And so on. See, this is my x of n. And the origin always starts from z raised to 0. So here the coefficient of z raised to 0 is 1, the value 1. So this is my origin. So you need to put the arrow mark over here. You see, so this is how I find that it is a causal signal. Okay, how did I find this as a causal signal? Because my power of Z are all negative. And how did I make the power of Z all negative? Because I rearranged this expression starting from the highest power of Z. And that is how I find the inverse of x of Z when x of n is a causal signal. Okay, this is the answer for the first part, if x of n is a causal signal. Okay, so now I'm going to do the same question assuming that the x of n is a non-causal signal. So how do you do non-causal signal? Means same procedure, but this time I'm going to represent this expression in such a way that it starts from the lowest power of Z. Both the denominator as well as the numerator, I'm going to start with the lowest power of Z. So let's do the same procedure using the lowest power of Z as the first term. In that case, this is question B, right? If the x of n is a non-causal, in that case your division will be like this. That is, you start with the lowest power. So here you can see that the lowest power, the denominator, the lowest power is z raised to minus 2. So how I am going to express this like this, that is z raised to minus 2 minus 2z raised to minus 1 plus 1. Okay, so that means z raised to minus 2 minus 2 z raised to minus 1 plus 1. Okay, this is my divisor and my dividend is, I go start with the lowest power. So my lowest power is 2z raised to minus 1. So I'm going to write like this, that is 2z raised to minus 1 plus 1. So that means this will become 2z raised to minus 1 plus 1. Okay, then I'm going to perform the same division as before. Then how do I make it and the trick is simply see to it that the first term of every step gets cancelled, right? So here it is z raised to minus 2 and here it is 2z raised to minus 1. So in order to cancel it, what I need to do is I need to multiply this with 2z. Yes, if I multiply this with 2z, then the coefficient is 2 and the power of z becomes z into z raised to minus 2 is z raised to minus 1. So you will get this value. So therefore this will become 2z raised to minus 1. Okay, and then in that case the remaining expression will be minus 4 z raised to minus 1 into z is nothing. So plus 2z, right? Plus 2z. Yes. Okay. Here because z into z raised to minus 1 is 0. So this will become z raised to 0. Z raised to 0 is 1 itself. Plus this is 2z into 1 is 2z. So you perform the subtraction. Plus will become minus, minus will become plus. Plus will become minus. First term will get cancelled and here you will have 1 plus 4 is nothing but 5 minus 2z. 5 minus 2z. So now what I'm going to do is I need to find the next number such that I will get 5 in the first term. When I get multiplied, I will get 5. So what I'm going to do is I am going to multiply this with 5z square. Only by multiplying this with 5z square, because 5z square into z raised to minus 2 is 5. So you will get 5 and then you will get minus 10 z and then you will get plus 5z square. Okay, and then you perform the subtraction. This will get cancelled and this will become 10 minus 2 is 8z minus 5z square. Okay, now I want to cancel this one over here. So this is I'm going to cancel it by writing plus 8z cube, because if I multiply 8z cube with z raised to minus 2, I will get 8z, right? So I will get 8z and then I will get minus 16z square plus 8z cube. Then I perform my subtraction. Minus plus minus, this will get cancelled and here you will get 16 minus 5 is nothing but 11. So you will get 11z square minus 8z cube. Okay, and then I'm going to do is I need to cancel this 11z square, so I will multiply this with 11z raised to minus, or z raised to 4. So if I multiply this z raised to minus 4, this will become 11z square, and this will become minus 22z raised to 4 minus 1 is 3. Okay, and you will get over here as plus 11z raised to 4, and you perform the subtraction. This will become minus, plus, minus, this will get cancelled. 22 minus 8 is 14, correct? So you will have 14 z cube, and here you will have minus 11 z raised to 4, and then next I am going to multiply this with 14 z raised to 5, right? 14 z raised to 5, so I will get over here 14 z raised to 3, and here you will have minus 28 z raised to 4 plus 14 z raised to 5. Okay, I think I have reached the end of the space. So this is minus and this is plus, this is minus, these two will get cancelled, and this will become 28 minus 11 is 17, right? 28 minus 11 is 17, so I will have over here 17. I'll have over here, hope you can see. Okay, yeah, so 17 z raised to 4, and this will become minus 14 z raised to 5. Okay. Okay, so now maybe I can write one more time also, right? Just to get one more term. The more terms you get, more accuracy your answer will become. So let me write 17 z raised to 6. Okay, let this be the last one. 17 z raised to 6. So then here you will get nothing but 17 z raised to 4 minus, here you will have 34 z raised to 5. 34 z raised to 5, and here you will have plus, you will have 17 z raised to 6. Okay, minus, plus, minus, this will get cancelled. 34 minus 14 is 20, right? So 20 z raised to 5 minus 17 z raised to 6, and this thing is goes. We'll stop till here. So this is the term. Okay, other words, your x of z is nothing but 2z plus 5z square plus 8z raised to 3 plus 11z raised to 4 plus 14z raised to 5 plus 17z raised to 6 plus, and it goes on. Okay, this is your answer. And see, one of the the answer that you got now here is that the power of z are all positive, right? The power of z is all positive. So since the power of z are all positive, then you know that this values that you see here, all these values come into the left side or the negative side of the graph. Okay, that is, this represents the value at n is equal to minus 1. This represents the value at n is equal to minus 2. 8 is the value at n is equal to minus 3. 11 is the value at n is equal to minus 4. 14 is the value at n is equal to minus 5. And 17 is the value at n is equal to minus 6, and goes on. In other words, your x of n should be written like this. That is, first you start with the least value. Here the least value is, this is the least value. This dot 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 is the least value. Then comes 17. Then comes 14. This is at n is equal to minus 6. This is at n is equal to minus 5. Then comes 11. Then comes 8. Then comes 5. Then comes 2. This is n is equal to minus 6. This is at n is equal to minus 5, n is equal to minus 4, n is equal to minus 3, n is equal to minus 2, and this n is equal to minus 1. So the amplitude of the signal at n is equal to minus 1 is 2. And the amplitude of the signal at n is equal to 0 is 0. That is, the value of the signal at the origin is 0. So this is where you put your arrow mark to show that this is the origin. See, so this is how we represent the non-causal signal. right? If the given signal is non-causal, then you apply the division this procedure. So how did you know it is a left-sided signal? Because the power of Z are all positive. And how did you make the power of Z all positive? Because over here when you apply the division, you rearrange the expression in such a way that the first term starts with the lowest power of Z. Okay, and then you perform the division procedure. This is how we do the long division method. Okay.